Welcome everyone to our webinar today about integration platforms and especially how Frends can help you with business intelligence and business reporting. My name is Asmo Urpilainen. I'm the Chief Product Officer for the Frends integration platform. But just slightly about the agenda here today. So basically, we're going to be taking a look at how Frends can help you build business intelligence and business reporting solutions and what types of kind of use cases Frends is really good at supporting, and basically what is the ideology and kind of overall architecture when deciding to utilize integration platforms in these sorts of business reporting use cases. And if we kind of jump straight down from the deep end a little bit, so just in a few words, what Frends actually is before we get into the matter at hand today, which is of course the business intelligence and reporting. So most of you might probably know most of all of this stuff, but it's good to go through it anyway once again. But just briefly, what Frends is. Frends is a purely browser-based enterprise-grade integration platform as a service, where we basically can implement any type of an integration use case imaginable, starting from APIs, and of course, Frends has a built-in API management suite directly on the platform, and of course, all the other more common, or I would say old integration use cases are supported just as well, starting from file transfers to data integration, and of course system-to-system integrations, and graduating to full-blown business process automation finally. And of course, today when we're talking about business intelligence and business reporting, we are going to be mostly focusing on, of course, the data integration use cases, since we are retrieving data, working with data, and preparing data so that it then can actually help us make decisions and can be visualized in a nice way. And of course, with Frends, you probably all know this already, but we utilize our own low-code approach to speed up the development of new integrations. And this should become quite apparent once we start digging down into the actual use cases we've built around the business intelligence and business reporting solutions, where we take this sort of a process-based approach to visually model out what the integration is actually doing, or what the kind of data pipeline, as we are often talking about in these sorts of business intelligence and data integration use cases, looks like. So the kind of visual aspect is always present when creating integrations with Frends. And finally, of course, what we are really good at doing with Frends is connecting these sorts of cloud and ground systems together. And of course, this is super critical when working with business intelligence and business reporting, since almost all customers have a situation where some of the systems are located in an on-premise environment, and some of the systems are probably then in a public cloud or even in a private cloud solution. But of course, we need to be able to access all of the systems in order to get the data flowing from the system through Frends to our actually reporting solution. And if we actually kind of maybe take a little bit of a step back here and think about kind of why are we interested in business intelligence in the first place? And of course, it all begins with basically a business need or a business use case, where you want to be able to make decisions based on data, and more preferably based on intelligent data. And in order for you to be able to do that, you of course need to have good data, your clean data, and the data quality needs to be as high as possible. And of course, the data needs to be also structured and linked together with other aspects of the data in order for us to be actually able to provide that intelligence in the business intelligence concept. And basically the way that you achieve the quality and structure on the data in order to actually serve or answer the business use case or business need, you need integrations that basically grab the data out of your systems and data sources so that then it can be displayed and structured. And of course, all sorts of data quality rules can be applied to it. So these three kind of main components are what we are of course trying to achieve with Frends today, is to first of all integrate or access the data wherever that data might be located, in whichever system the data might be situated. We want to structure that data. We want to actually be able to link the data with other data dimensions, or actually completely separate data sets. And finally, of course, we want the data to have high quality, so we need to be able to do all sorts of validations and basically checks on the data. Is the data, let's say, on a high enough level that we can actually bring it to the user to be able to make those decisions based on that data. So these are the three main questions that we are going to be kind of tackling and going through today. And just a little bit about kind of the high level approach or ideology to set the stage before we get into the more interesting slides with architectural descriptions and pictures and so on. So we are talking about this sort of a more modern BI architecture, which is quite different from a traditional master data project or this sort of a master data management ideology that many companies still utilize today. And what we feel that a modern business intelligence architecture should actually enable for the customer is basically exactly the same set of benefits that basically microservices offer as well, meaning that basically the kind of complete BI solution or BI architecture should actually utilize a decoupled architecture, and a little bit about that later down the line. But most importantly, it should be actually quite well scalable. It should have continuous delivery or basically this sort of a componentation approach enabled. And basically the solution should be fast to develop and fast to debug and maintain. And basically and of course, because what we are trying to achieve or pursue these sorts of ideologies or considerations, like I mentioned, they overlap quite a bit with the kind of microservices ideology. So I will actually be calling the solutions or components that we use with Frends to enable all of these business intelligence use cases, BI mini services, because they do have the benefits of microservices, but they still do have the dependency to the actual underlying backend system, which of course acts as the master for all of the data that we are actually going to be processing. And what this actually kind of means from a practical perspective is that what we want to do is build the business intelligence or business reporting capability in smaller increments, meaning that we don't want to have this sort of a 12-month master data modeling project at the very beginning before we can actually display or show anything to the user or the owner of the data, but we actually want to start generating value and basically enable the solution to be able to utilize from the basically day one, and then we incrementally increase the capability and benefits of the solution by adding in more and more of these, let's call them BI mini services, like I mentioned before there. And one kind of key ideology to consider in this sort of a use case is that when we are talking about these BI mini services, and of course we'll go a little bit deeper into that in just a moment, we don't want to take a more traditional approach like I mentioned as typically customers do with these sorts of master data projects where you model out all of the data possible in your organization and build a nice data model based on that. And typically, because we don't want to go down that route and we want to kind of get the ball rolling as soon as possible, one key aspect that we need to consider is that we quite typically never use relational data or relational data structures in this concept, meaning that, for example, we don't want to build a traditional SQL server schema or a data schema where we use foreign keys and primary keys and identifiers and things like that to basically connect the data together, but rather we focus on the data itself. So, for example, we don't want to say that, okay, ID for, let's say, customer and a contact is ID number one, and that ID number one is the connecting factor. But instead we say that, aha, yeah, actually a customer might have contacts which have email addresses, and those email addresses have typically the same domain as the customer website. So we actually now utilize the data itself to provide these sort of more understandable real life relationships between the data and try and avoid these sort of artificial, I would say, technical implementations of the relations for the actual data itself. And the whole ideology bit behind this sort of a BI mini service approach is that now we can actually, when following these rules and I would say ideas, we can actually manage all of our different dimensions of our data set. So the whole data we have available at an organization individually, and basically have each of those kind of aspects of that data be its own separate scalable mini service. So for example, a customer data could be this sort of a BI mini service, and we only focus within that mini service on how do we get the customer data into as usable and or as a nice quality or to a nice enough quality as possible. And of course, one kind of huge major benefit there is if we are working with individual data sets, this means that also we can of course work concurrently with multiple data sets. And of course, extending the data set is super easy, because basically we just keep on plugging in these sorts of BI mini services. And pretty much to kind of maybe elaborate this ideology a little bit further with an example architectural picture here, where basically we have our systems of record here at the bottom. So we have an ERP, CRM, workforce management, HR, and product information management systems, which actually have now been split into two separate environments. So we assume that our HR and product information management system are in the cloud, but then our ERP, CRM, and workforce management are still in an on-premise environment. And now what we of course want to build is that nice data set, that business intelligent compliant data set, in this case, for example, utilizing an Azure SQL server. And we'll go a little bit deeper later down the line on what sort of, let's say, data warehouse or data storage options actually work the best with this sort of a modern BI approach and architecture, since the basic principle here should be quite apparent. So here we actually have all of those BI mini services, which I just described, where we have some examples of them. So obviously we didn't have space on the slide here to put all of the possible aspects of the data there. But just to give you the ideology on how the BI mini service works. So we could think, for example, let's say take the customers example, as we mentioned that on the last slide, that the CRM system now acts as the master for all of our customer related data. And now what we want to basically build with our BI mini service targeting customers is the ideology that we should have a single solution that's able to basically always connect to all the necessary systems that contain our customer data, and basically form and structure and basically apply those data quality aspects to that data by first, of course, integrating the data into the Frends platform, applying all of the different quality gates or steps along the way, and finally, of course, harmonizing and let's say inserting that data into the actual data warehouse, which is in this case is an Azure SQL server. And then of course we could utilize an existing or a pre-built BI tool to connect to that nicely structured database now to display our customer data. And the key kind of difference here is that now let's think from this from a little bit of another perspective. So if we have our customers, and customers typically, for example, have either sales or revenues. So now rather than artificially trying to link these two data sets here on our data warehouse together, we actually treat them completely separate and completely independent from one another. And the only thing that we ensure is that all revenues must have at least one aspect of the data which tells that piece of revenue data who the customer is. And typically in this case, for example, that could be the website domain. And now, of course, because both our ERP and CRM system quite typically actually are able to link these two bits of data together, utilizing, for example, the email domains or the website domain of the customer, we can actually treat these two sets of data independently. And then finally, on the BI layer, we start actually connecting those two bits together. So we create that data cube there on the BI tool rather than in the integration or data warehouse layer. And this is actually the approach that many of the modern, I would say, business intelligence tool providers are pushing. So for example, ClickView, Tableau, or Power BI are actually developing more and more features to manage the relationships of the data in the BI tool rather than on the, let's say, data storage layer or even in the integration layer. And now, of course, we can actually have the capability of having all of these separate BI mini services, and each of which, of course, can work completely independently. They can, of course, work together by having that chosen, let's say, aspect of the data which provides the capability of doing the data linking in the business intelligence layer, or of course we can even have a capability of running each mini service or each BI mini service in that environment where we can actually access the systems themselves. Perfect. So going a little bit deeper into an example on this sort of a BI mini service ideology, typically what this sort of a business intelligence mini service might look like on Frends is, of course, now we utilize that low code aspect of Frends to actually define and describe the mini service in this sort of a process-based approach using the BPM and 2.0 notation, which of course we can now trigger with both a webhook from our CRM system. So we can, of course, subscribe to changes in the data in the CRM system. So we can have this sort of a streaming ideology in place, but also we have a schedule in place. So typically what we, of course, want to achieve with these BI mini services is that they should both support this sort of a streaming real-time only update the delta of the data, as well as that is sort of a larger batch style job. And the reason that we are mixing these two approaches together, or these trigger mechanisms together, is that sometimes we might have some issues with, let's say, the CRM system not triggering our webhook even if it's supposed to. So then we want to make sure that we still grab all of the data every fifth minute, even if the webhook is actually running there. And that actually leads us to the kind of following part of the process, where first we of course get all of those changes from our CRM system. And here we, of course, can utilize those Frends pre-built connectors quite effectively. And depending on if it was a webhook, we basically just grab that one single customer that the webhook provides for us. And if it's a schedule, we basically grab all customers that have been updated or created since the last 5 minutes that we actually run the solution. And of course, after we get all of our customers into the mini service, what we want to be able to do is iterate through each new or updated customer we find. Depending, of course, in a webhook use case, we only run one iteration. Or of course, if we get, let's say, 100 new changes in the last 5 minutes, then we would iterate through all of those 100 customers. And quite typically, what we of course then apply in our process is that we visually basically define the quality gates for the data. So in this case, we have 3 quality gates that the customer data must have. So it needs to have an account owner set. So this is actually an example from our very own HiQ reporting, which I'm using as the basis here. And when, of course, we're calling our customers have account owners. But of course, we also check that the customer has a website set, since quite typically the data in the CRM isn't as nice as it of course should be. And finally, we just simply make sure that the customer is active, and then we basically perform a simple upsert functionality. So we first detect, is that customer already present in our Azure data or Azure SQL data warehouse? If so, we basically perform an update, and if not, we create that customer in a new case. And of course, now we might have a situation where, let's say, we have some customers where we don't have, let's say, the customer website set, meaning that we actually skip that customer completely in this execution of the mini service run. But the last thing we, of course, want to do is send out a report of all of those invalid customers that we were not able to pass through our quality gates. And quite typically what we want to do in this sort of an approach is always have the master of the data, so in this case the CRM, so that we actually fix that data directly in the CRM system. And of course, once we fix or update that data, that update automatically triggers a new run for that customer. So we actually then automatically end up that particular customer being processed in the correct way. And often actually what we what we do is we might actually target, let's say, the salesperson, so the account owner directly, and send the account owner, let's say, a Teams message or an email asking them, all right, could you please go and fix the website for our customer? And this way actually we also tackle a situation where if our data is not in tip-top shape once we start our BI project, we can actually still get that data flowing and generating value, which is good, and then slowly but surely kind of keep on bugging people as long as it takes to actually then fix the data and kind of teach users and actually providers of the data to work in this way that it makes sense from their perspective. Brilliant. But moving on to maybe a little bit of a more detailed description on what we should do and what we shouldn't do. So maybe some thoughts about the data model that we actually provide or create here in our data warehouse or data storage, whichever solution we actually might choose. So this is coming back to what I said in the beginning there, where we don't want to have this sort of a tightly connected data set built, for example, using foreign keys and primary keys and these sort of enforceable relations, because this would, of course, now ruin the whole ideology behind that BI mini service. So if there is a dependency between customer and project in the kind of technical implementation of our data storage, this means that we cannot have, for example, projects which don't have a customer or vice versa. And of course, that's typically not the case, especially in the beginning where we don't have all of our data in tip-top shape, like I mentioned. So we need to have that loosely coupled data model in place. So rather than technically forcing that foreign key, let's say, constraint on the data, we actually just agree and ensure in our integration process or BI mini service that all of the necessary aspects of the data are present. And if there is a dependency, so we can agree that, all right, you cannot have projects without customer, but then we basically perform that check as part of the mini service instead of generating an error then from the data storage or the data warehouse itself, because this will now actually allow us to take that approach where we gradually, piece by piece, kind of improve, first of all, of course, the coverage of the data, so the different dimensions that exist, but of course the linkage between that data and the quality of the data, so that then after a while we end up in that nice 99.9% coverage for all of our data. So we kind of allow and assume that the data is bad in the beginning, and the whole ideology is built around this principle that we want to kind of transform the way that you think about the data and the way that you use the data in the systems so that it would always be correct. And that's where, of course, the BI mini service comes into play. So don't do it like that, not with foreign keys and of course primary keys and kind of artificial relations, but loosely coupled architecture with actual understandable relations between the data itself. And some of you might be now asking, but hang on, you can't create a relationship between a customer domain before the project and customer, because that might not be unique. But the clever thing about this ideology is that we basically look at the different dimensions of the data and figure out that, aha, all right, actually, customer domain is a real life value that is actually always unique. So there are various different reasons why in the real world you cannot have two separate customer entities actually utilizing the same domain, because that actually is even, I think, legally prohibited in many cases. So even if we don't have that technical artificial, let's say, enforcement of the relationship in the data, the real world typically nowadays provides us with exactly the same capabilities, with the difference that we are now not facing, I would say, the difficulties that we have when working within this sort of a more traditional data warehouse or master data approach. But basically, some words about the actual underlying data storage. So typically when choosing this sort of a data storage option there, most, I would say, database technologies are suitable for this BI mini service approach, because we are not reliant on the functionality or features of the data storage or database to provide us with that connectivity or relationships between the data, but instead we are building the relationships on the BI tool and then enforcing them in the BI mini service in the integration layer. So that actually means that what we should also only consider when choosing our data storage is what is the most fit for purpose tool for my particular kind of data. And some examples where we've had great success with are, of course, some of the Azure platforms there, so the more traditional SQL Server, and of course the no model Cosmos database. But other options like PostgreSQL have been found out to work really well as well, even we utilizing some of the more newer and trendier technologies, like, for example, Snowflake, are perfectly suited for this type of an ideology. And the things that you should kind of be on the lookout for your data storage is, of course, everything relating to security. And of course, hopefully or most likely, you should have some sort of authorization features available, so that then you can actually restrict access to your data, because you might have personnel who are able to, or who should be able to, access the customer data, but not project data, and vice versa. And of course, the data storage is the layer where you provide that authorization context. And of course, some sort of tracking features, analytical stuff, and things like that are always a nice bonus and a fit on top of that. But one thing to mention regarding the data storage here is that with the kind of BI mini service approach, we are actually able to even mix and match different technologies depending on the use case. So we might have a use case where we have some of our data in, let's say, an Azure SQL server, but then we might have some sort of data lake for, let's say, some of our larger data sets like IoT data. And typically, of course, because each BI mini service is responsible for only working with that one set of data, and it has a single target in the data storage or data warehouse, we can of course choose which solution, which data storage, which data warehouse we use, basically on a per, I would say, BI mini service basis. And it's no problem for those modern BI tools to actually connect to multiple different separate databases or data storage options, and then combine the data in the BI layer, like I mentioned earlier. Just in a couple of words, we could actually take a look at the BI tools themselves. So we covered this a little bit already previously, but typically what customers choose to utilize for the BI tool to actually provide the visualization and the data cubing to work with the data are either ready-made BI tools such as Power BI or ClickView or Tableau, like I mentioned previously. And we of course see some customers using a more customized reporting solution, typically built from the ground up as a website project, or it might be some sort of let's say a custom solution that can be extended or configured by doing some sort of development, whereas these sort of Power BI and ClickView are more tailored to have this sort of ease of use or a nice user experience. But basically, what you should kind of consider when picking your BI tool is, of course, the capability of creating those relations on the BI tool directly. And here, actually, I have a sample screenshot from Power BI, where we've actually built now the kind of high-Q reporting system utilizing these sorts of BI mini-service ideology, where basically the relationships between all of the different kind of aspects of the data that we are dealing with, each of which have, of course, their own BI mini-service, we can now model the relationships. So, for example, we could have or revenue or a project or customer and project could have one-to-many relationship. So these, of course, follow the more traditional rules of building out the relationships, but we actually model the relationships on the BI platform rather than in the integration layer and in the data storage layer. And of course, having real-time access to the data is a huge plus, because if we are working in a situation now where we typically want to have both the real-time stream option available, so within seconds we'll have the change ready in our data set, as well as the more traditional batch style job, but both would be something that we can utilize at the same time in our BI mini service. Now it's actually super good that we would be able to see that change immediately in our data. So having that real-time data capability is definitely something that you should consider, as well as, of course, providing that access control layer, like mentioned earlier, saying that who and which, I would say, user is actually now able to access what layer or level of the data itself. And maybe just with a couple of words about the actual mini services before going into a couple of real life examples here. So things that you should consider when thinking about these BI mini services that provide you with that data functionality is that, I've created this definition kind of myself here, but in order for that kind of BI mini service to be called a BI mini service, I think it should always be able to implement both the mass update functionality as well as that streaming delta only or only change functionality. And there, of course, we have all of these various different ways of working with the integration platform to provide us with this capability, even if the system itself is not that capable of providing us with this functionality. But of course, at the same time, like I mentioned, so both the kind of update everything at once and only the changes, we should have the real-time streaming ideology. So quite typically, this would be a webhook of some sorts or some sort of a subscription mechanism to the system. And we should also have that batch job style processing available at the same time. So and kind of like working with this ideology, we have to build the services to be resilient, meaning that we don't expect the data to be perfect, and we think that some data is better than no data at all, as long as the data is correct that we actually allow through the BI mini service. And this, of course, is linking to the other side of the ideology, like I mentioned before, that we always keep the systems where the data is situated as the master, and we want that data to be fixed in the master system rather than, let's say, be fixed manually on the integration layer or in the data warehouse. So no developer or operator should actually ever be working directly modifying the data in the data storage, and it should all stem from changes in the data in the master systems themselves. And of course, that leads to be able to have those alerts or notifications for those people who are responsible in updating the data in the systems itself. And finally, in order for a BI mini service to be qualified, it should be able to work standalone, and it should be able to actually provide you with some value for the data, even on its own. So even if you have just a single BI mini service, you should be able to do something with that data. And the most importantly, you should be able to actually run that BI mini service. So it should be resilient also in that way that if you are running, let's say, multiple updates at the same time, those don't actually clash and create problems in the data. So you should actually be able to have even, let's say, 100 instances of the BI mini service running at any given point, and they could even be processing the same data, and that still should not create any problems in the processing of the data itself. And maybe just a couple of kind of real life examples here in the end. So typically kind of like we have a setup here, which is actually our BI architecture. So you can actually see our business systems that we are using here for all of our data. So we have a plan mill and Jira and of course HubSpot and things like that. Some of them are located in on-premise and some of them are located in public cloud. And of course now we use the agent architecture of Frends to access the on-premise systems here in the on-premise environment, and of course the cloud agent to access the cloud systems there respectively. But more importantly, maybe just as a, I would say, real life example on this kind of ideology that you should have that batch job capability or a streaming capability for the same data. So this is an actual integration that actually is now gathering data from our HubSpot to our reporting system. And the ideology here is that, of course, we have the same functionality in place, that we either run all customers that have been updated or created every day, so in the last 24 hours, or we can have a single update, single customer coming in through the HubSpot webhook. And now to actually make this a BI mini service, what we need to be able to do is actually have the functionality of being able to, for example, go through the entire list of customers in HubSpot. So of course, this is a little bit of extra work, but this kind of pays off in the end, because now when we have implemented this feature and functionality where actually we are able to kind of loop through all of the records in HubSpot, which could be tens of hundreds or tens of thousands or hundreds of thousands even in some cases, we now can quite easily control if it's a single update or if it's, let's say, one to n amount of updates we should be processing. So first we either grab a single customer or we grab all the customers which fit our criteria. And then quite simply, we just have some of our quality checks in place and basically do our upsert functionality, where if the customer does not exist, we of course insert that customer. If it exists but has not been updated, we skip that customer. So we can of course utilize different sorts of timestamps in the data in the systems to make those decisions what should actually happen when dealing with each and every customer. But maybe another example from a little bit of another perspective. So this is actually a little bit of a more tricky use case and something that I would say speaks to the benefits of this sort of a BI mini service approach, where achieving something like this without this sort of a BI mini service approach would be quite difficult. So we actually have a use case here where we want to track a given project, an implementation project here at HiQ, where basically we are using Jira for the kind of management of the work, and basically we want to be able to see how long it takes in basically calendar days for each ticket to basically be in any given state. And for whatever reason, the Jira API does not provide us directly with this information, meaning that we actually need to first get all of our tickets, or I would say these sorts of issues for our given project in Jira. We iterate through each ticket and of course get that single ticket data. And fortunately, there is an endpoint to access the change log for that ticket, even if we can't get, let's say, the durations for each stage automatically, we can get the change log. And of course, from the change log, we can now grab all of the updates to a status of the ticket, which is basically an array of these three JSON documents as an example for my example ticket here. And basically the change history now tells us that, all right, at this date and time, we have actually moved the ticket from InDesign to queued stage, meaning that actually now we can go through each of those changelog entries for my given ticket and basically pick out for, of course, the first one and kind of try and find out and see that, aha, if the first entry is, of course, a change from InDesign to queued, is there a previous change available? And of course, because it's the first entry, we don't have the previous entry available, which means that now we actually can calculate the duration for the InDesign phase, basically from the date that the transition was made into basically what is the current date and time. But of course, if we move on to the second stage of the transition, then we can see that, aha, yeah, at this date and time, we have moved from queued to implementation. And now, of course, we can find the previous queued state from the list that it has a separate date and time. And then we can actually take the difference between these two dates and times and grab the actual duration of that stage. And finally, of course, we then just actually insert those values into our data storage and be able to actually work with that data. But this is just an example. So of course, the benefits here is that we are not able to, of course, cheat here because we are hooking directly into the change management system of the Jira system itself. But also we can actually do kind of this super complicated calculation, basically, even if the data is in this sort of a really horrible format than what we would actually like to achieve with that data. That's no problem because we have that integration logic in place for us. And of course, we would be more than happy to discuss with this further with any of you. And I will have to thank you for your time at this stage, and I hope to see you in our next webinar. So, all right, thank you, and bye-bye.